We used to think we could simulate the birth, life, and death of everything out there. Stars, galaxies, the whole shebang. We thought we had it all figured out. Then the James Webb Space Telescope showed up. It wasn't just built to casually look around. It was designed to peer way back into the early universe like a time machine. It was supposed to be our best shot at understanding how it all began. But what it saw didn't match the textbooks. It didn't make us feel good and certain. Instead, it shook things up. In what seemed like a quiet part of space, Webb spotted something strange. A super bright galaxy was glowing so intensely that astronomers first thought it must be close. But when they measured its red shift, how much the light stretches as space expands, they were shocked. This galaxy, called CS 93-316, had a redshift of 16.7. That means its light started traveling to us only 230 million years after the Big Bang. In space terms, that's like being right there when the universe was born. But what Webb saw wasn't a baby galaxy. It shouldn't have been possible. Stars, if they existed at all, should have been rare and simple. If it was just one galaxy, we could call it a weirdo. But there were more. Webb kept finding galaxy after galaxy, all older than they should be. They didn't match our current understanding of the universe in terms of size, shape, and what they're made of. So, astronomers did what they always do when things don't make sense. They did the math. They calculated how big these early galaxies were and discovered some were already as big as our Milky Way, only a few 100 million years after the universe started. Think about that. It took our galaxy over 13 billion years to get this big. These ancient galaxies seemed to skip the slow part. According to our models, there shouldn't have been enough time for gas and dust to cool down and form stars, much less huge, complicated galaxies. Yet, there they were, with star clusters and neighbors like a whole impossible town of galaxies. If it were just one, we could maybe explain it away. But there are too many. This means one of two things. Either we don't understand how galaxies form, or we don't understand the timeline of the universe. Some of these galaxies also seem to have used up all their star-making material, leaving behind older stars in a universe that should have still been brand new. The standard model says gravity, dark matter, and dark energy gradually shaped the universe. But these massive, mature galaxies so early on contradict everything we thought we knew. And the more Webb sees, the bigger the problem gets. It looks like the early universe was a much faster, more energetic place than we thought, churning out galaxies in a wild rush that our current theories can't explain. These findings are a punch in the gut to cosmological physics. The redshift data even suggests these galaxies are beyond the Hubble horizon, the distance from which light shouldn't have reached us yet. If we can see them, either we're wrong about how fast the universe is expanding, or something even weirder is going on. Maybe the shape of the universe isn't what we thought. Maybe time acts differently at cosmic scales. Maybe light doesn't travel the way we've always assumed. For over a century, the Big Bang has been our best guess for how the universe started. It explained a lot, but now it's starting to seem like a patched-up theory full of guesses that don't hold water anymore. Webb is exposing these weak spots. Alternative ideas, which used to sound crazy, are now gaining traction. Could we be wrong about the most basic ways we measure the cosmos? It's not just wishful thinking. With each new thing Webb sees, these ideas become more believable, not because we want them to be true, but because we need an explanation. Then there's dark matter, the mysterious stuff thought to hold galaxies together. It's been a key part of the standard model for decades, but Webb is now making us question it. The ancient galaxies Webb sees don't act like they were shaped by dark matter. Their structure, how their mass is spread out, and how fast they formed suggest either a different kind of dark matter or no dark matter at all. If dark matter isn't what we thought, our whole model of the universe falls apart. All of this paints a completely different picture of the universe, one that we're only starting to see. It might be totally different from what we've imagined. Webb isn't just taking pictures. It's challenging everything we thought we knew. Its images hint at laws being broken, assumptions being wrong, and theories needing to be rewritten. As we get more information, it's clear that we're at a turning point. We used to think we had the answers. Now we realize how much we don't know. The early universe, instead of being a slow, gradual process, seems like a chaotic explosion of complexity, a rapid acceleration of matter into form that our best minds can't explain. The future of cosmology might not be about tweaking a model. It might be about starting from scratch. That's not failing. That's science at its best. Letting go of what we think is certain and embracing the unknown. The James Webb Space Telescope isn't just a telescope. It's a game changer, a mirror showing us not just the past, but how limited our knowledge is. And what we're seeing is humbling, exciting, and just the beginning. Ever since humans looked up at the stars, we've made up stories about them. For over a century, these stories seemed solid. It all made sense, or so we thought. Then came a machine unlike any other. Instead of confirming what we believed, it started tearing it apart. One of the first oddities showed up in a seemingly normal part of the sky. According to every model we have, this galaxy shouldn't exist. And it wasn't alone. As the telescope looked deeper, it kept spotting more of these old, gigantic galaxies. Each one directly contradicted what we thought was possible. These weren't small, struggling galaxies just starting to form. They were huge, complex, and some had already used up all their star-making material, suggesting a burst of activity that shouldn't have happened so early in the universe. The implications were huge. To form galaxies that big, that fast, the universe must have either changed much more quickly than we thought, or the physics that controlled its early expansion were wrong. There's no in-between. The deeper the telescope looked, the louder the contradictions became. Scientists did the math to figure out how much matter, gas, and dark matter would be needed to build these galaxies so quickly. The numbers didn't add up. Some of these galaxies seemed to have the mass of the Milky Way, formed not over billions of years, but in a tiny moment of cosmic time. According to the standard model, this simply couldn't happen. The early universe was supposed to be full of radiation, chaotic with energy, and not friendly to structure. And yet, structure kept appearing. It gets weirder. These galaxies weren't alone. They showed signs of being grouped together, forming cosmic neighborhoods, talking to each other, and creating gravitational patterns that suggested not just survival, but community. That kind of organization so early on suggests something huge. Either the timeline we've created is wrong, or there's a hidden way the universe builds things that we've never even imagined. As Webb captured more images, our models of dark matter, the stuff thought to shape galaxies, started to fail. In some of these early galaxies, the amount of dark matter needed to hold them together would have to be so high that they would collapse into black holes. In other areas, there seemed to be too little dark matter for galaxies to form at all. And yet, there they were, massive, mature, and full of bright stars. This isn't just a small problem with the theory. It's a sign that dark matter itself, which we've long believed to be the silent builder of the universe, might not act the way we've always thought. It might not exist at all, or worse, it might be a placeholder for something we can't yet name or understand. The contradictions didn't stop there. Time itself started to warp under the telescope's gaze. Some galaxies seem to contain stars older than the universe should allow. This isn't just a math mistake. This is a break in how we understand cause and effect. It suggests that time might not flow the same way throughout the universe. Maybe under strong gravity or strange quantum conditions, time slows down, speeds up, or even folds. If time isn't constant but something that changes based on conditions or comes from deeper physical laws, then our whole understanding of cosmic history needs to be rewritten. Imagine if time isn't a straight line but flexible. If the cosmic clock doesn't tick the same way everywhere, but is a shifting haze depending on things we haven't yet understood. This opens the door to wild ideas, like time only starting after things become disordered enough, or light traveling at different speeds at different times in cosmic history. Suddenly, the past might not be as fixed as we thought, and the future even less so. Among these strange discoveries, Webb might have also found hints of something we've long theorized but never seen: population 3 stars. These were thought to be the first stars ever formed, huge stars made only of hydrogen and helium that lived short, explosive lives and created the heavier elements that seeded later stars. But what Webb is seeing doesn't quite match the models. These stars seem too big, too hot, and too unstable even for population 3 stars. They don't follow known life cycles. Some astrophysicists are wondering if these could be signs of something new altogether. failed black holes, exotic matter centers, or even fusion events from before galaxies formed that we don't yet understand. The deeper you dig, the stranger it gets. Webb has spotted patterns in how galaxies are spread out and rotate that stretch across billions of light years. These patterns aren't random. They're statistically significant. Repeating structures, aligned spins, symmetries that almost seem designed. The usual explanation of a universe shaped only by chance, gravity, and expansion starts to break under the weight of such precision. Some theorists are starting to consider the unthinkable, that the universe has some underlying order that defies randomness, that there might be a basic building block of information beneath reality that maintains symmetry and maybe even has a purpose. This isn't just speculation. Some believe these repeating patterns could be evidence for the simulation hypothesis, that the universe isn't a physical thing at all, but a generated program following coded rules. Others think we might be catching a glimpse of quantum consciousness embedded in the cosmos, or that the fabric of reality remembers, responds, and changes in ways we can't yet detect. And still the images keep coming. Silent pictures of impossible beauty, galaxies that look back across time, not as ghosts of the past, but as witnesses to how limited our understanding is. The James Webb Space Telescope hasn't just changed what we see. It's changed what we can believe. The universe no longer fits neatly into our models. It spills out over the edges. And in those gaps, in that terrifying, magnificent uncertainty, lies something more powerful than knowledge: wonder.